Okay, so as I was saying, hopefully we don't have any more disturbances. As I was saying, a couple of things I want to point out. When you see a triangle or any shape for that matter that is drawn, anything with angles, anything that have sizes, it will usually say not drawn to scale. And it's important that you appreciate not drawn to scale, because sometimes, for example, if you see a triangle, if you based on how you see it, it may look like, for example, a right angle triangle, but it's not necessary. But it be based on how it looks. So, for example, the triangle might look like this. Sorry, that's 4. So you know how a right angle triangle supposed to look, right? A right angle supposed to look that 90-degree perpendicular thing. So when you look at the triangle, it might look like a right angle triangle, but if the question say not drawn to scale, if the question says not drawn to scale, or if you don't see the little box in the corner, for example, you don't assume that it's a right angle triangle. You assume that it could be anything. And until you work it out, you don't know. All right. So just bear that in mind, because a lot of times people use how the diagram look when you can't. If it doesn't say drawn to scale, or if it doesn't tell you the angle, don't assume anything, all right? That's the first thing. The other thing I want you to bear in mind before you think about this question is sometimes how they can represent angles. Now, an angle in layman term is where two lines meet, right? Anywhere that two lines meet. So if I have this line and that line, where the two lines meet, which is here, you have the angle. Now, if this is called H, I, and J, persons can refer to the angle in several different ways that I want you to be aware of. You can just simply say angle I to that, because this is I, so they just say angle I. Some books, some questions will say that. Some books and questions will say angle H, I, J, and in the event that that's how they write it, you know that it's the middle one, that is the angle, right? So that is in the middle, because sometimes if you have, for example, another line here, you also have an angle here and an angle here. But depending on which letter is in the middle, that is the angle that they're referring to. Sometimes they will write it like this, angle H, I, J. It's the same thing. And sometimes they will write H, I, J, and they put a little thing like that over it, the angle. It's the same thing, all right? So I just want you to be aware of how they represent it. So in our question today, if the question is written to say find angle ADC. So you know when you say ADC, the angle that you're looking for is this one right here, ADC. And when it says BAC, you go and you say BAC, the one that you're looking for is this one right here. All right. So go ahead, take 5 minutes, figure out how you would find it. Remember, we're doing trigonometry. So you're thinking about how can you use the sine rule, the cosine rule, the trig ratios probably to solve this question here, all right? So I'll give you 5 minutes. You'll think through it, and then we will return. We'll come back and we will discuss your thoughts as to how to solve the problem before we actually solve the problem. Everybody is good with that? Everybody is good with that? All right, so let's go. 5 minutes. Think about it, and then we'll come back. All right, so anybody wants to share with me what they've thought about so far in terms of how to go about finding the first one, angle ABC, which is, let me just put it in a bright color. Let's put it in green. Anybody, how you go, how you think, what have you been thinking about now in terms of how to find it? You need more time to think about it?
Yes.
Miss,
You hear me?
Yes, I'm hearing both of you, so one go first.
Go, Karen.
well, me did I say probably me try split them in a two. And then me did I try use the sign and it confusing so much. Me say, all right, me I gotta use the cosine. So me stop this at the cosine. Me name stop.
So why you decide that the sign can't be used anymore?
Oh God. Because um as we said, each of them have them own angle and the big A have the what did I call this? The 34-degree and then this big C and the D not have it. None at all. So me no know.
Don't know. All
Yes,
right.
that's what
Shauna?
that was the same thing I was looking at. I was saying that keep them in two and then find you will look at it and find out which if it has two angles or not. If it doesn't
Mhm.
have two angles, which you would need to use the sine rule. So I'm trying out the cosine rule. With it.
So did you try the sign rule first?
No,
You didn't?
no, I didn't try the sine rule first.
Why?
Looking at it, look, I realized that it only had one angle,
Uh-huh.
which I could use. And then for the sine rule is you need at least two known angles or two known sides in order to work the operation.
But you have two known sides.
Yes. Oh yes, I
Remember,
have the 10 and the
remember
I
right
have
here,
10
so say, I just
right.
provided you with information. So remember right here, so say AD is the same as
Uh-huh.
AC, which is 10. So you could literally put 10, this is AD, and you could put 10 right here, so which is AC. So you have those two
But
sides, remember that.
that means you could have used both the cosine and the sine rule.
You
Looking
could.
at it, you could have
All
used
right, try, all right, remember you're trying to find the angle D, this angle over here. So,
yes.
so tell me how you would use the sine rule to find it.
If I'm going to use the sine rule,
Sorry, so let me help you by writing out the sine rule. So for the sine rule, you need A over sine A equals to B over sine B, where A, small a, is a side, and sine and big A is the opposite angle,
but
and small
Miss,
b
look
is
at
a side, and
in
big
this
B is
sense,
the opposite angle.
Miss, in
Melanie?
this sense, you wouldn't have a sine B. You would have a sine B because you're looking for the angle ABC.
At
All
that
right,
me I
So
say,
all right,
that
at
hold,
that
triangle would be
confused with.
ABC.
hold on. So let us just fix that from now. A and B are arbitrary. By
Yes.
arbitrary, I mean a triangle doesn't have to come with the side or the angle named A and B, right? Remember when we do
Okay.
the first, remember when we did the sine rule first? Let me just draw back a triangle over here, right? Remember when we did the sine rule first and we said, let me just finish drawing this triangle just to remind you, A, B, C, right? We call it ABC. And we said ABC is arbitrary, meaning that we could literally name these three angles anything, right? But what is important is that if you have an angle over here that we're going to call big A, the opposite side is small
Yes.
a, and then the opposite side over here, so it's small b, this is small See, what is important is the relationship between the angles and the side. So it doesn't matter if I draw a new triangle. So if I were to draw a brand new triangle and I name this angle X right here, so Y and Z, it would still be the same principle. Over here, so would be, hold on, small x, the opposite side would be small y, and this opposite side would be small z. And then I can express the formula, express the rule by saying the side over the sine of the corresponding angle is equal to the side over the corresponding angle, and I can do it for all of them, right? The point I am making is that the letter of the side, what you call it, whether you call it A, B, C, X, Y, Z, H, I, J, it doesn't matter. It's the ratio that matters. So what you need to concern yourself with is that this is the angle and this is its opposite side. That's what you need to consider. So you can name it D if you want, or you can name it, it don't matter what you call it. But this, but
what I've also
go ahead.
What I've also observed is that if you're using the sine rule, you'll have two unknown parts to it.
Okay.
Or you only know one angle. You only have one angle to use. You wouldn't know the other.
All right, I understand that. Before we go there though, have I cleared up the issue about whether this is D right here? It's about the formula having sine A and sine B. Have we cleared that up?
Yes, ma'am.
Oh, I want to make sure we clear that up first. It doesn't matter, right? It don't matter what you call it. So I can rewrite this formula, and instead of saying A, I can call it small d over sine D, which is big D, equals to, if you're going to use A or C, I can call it anything, right? What matters is the relationship between the side and the angle. So that's clear to you guys.
Yes, ma'am.
All right, good. So you're saying now that looking at it, you can't use the sine rule. Tell me why you think you can't use the sine.
Means because you'll end up having how should I put it? You'll end up multiplying two unknowns.
So you're going to have two unknowns in it. So for example,
two unknowns.
So you're going to have two unknowns in the formula. And if you are working a formula, you can't have more than one unknowns, right? So for the benefit of the rest of persons in the class, let us just show. So we have the sine rule, and just for simplicity, we're going to be using the letters that are there in the triangle. So we're wanting to find this angle, which is angle D. So we're going to call the opposite side of it small d, right? So if we're using the sine rule, it would have to be small d over sine of big D, and then we would need to use this here, which is this angle, and this would be its opposite side, and that is angle A, so we're going to call this small a, equals to small a over the sine of angle A, right? So if we're going to try now to solve it, small d is 10. The angle D is, we don't know, that's what we're trying to find. And then A, we don't know again, because it is DC, we don't know DC over sine 34. So the point that Shauna is making is that we can't use the sine rule to solve, just to find the angle D here, because we will end up with two unknowns. I'm going to circle them yellow. You're going to end up with this D unknown right here, so which is an angle. And you're going to end up with this A up here, so which is unknown, which is this side right here, so, right? And you can't, if you have two unknowns, you can't solve for anything. So we accept that we can't use the sine rule to find angle D. Everybody understand and appreciate that?
Yes, miss.
All right, so we can't use sine rule. So let's go again. Let's think again. Put on our thinking caps and let's go again. No thinking cap, finish already? What's next? What's your next step? You're in exam and this is a question on your paper. You just find out you can't use the sine rule. What is next? What next do you try?
Try the cosine rule. But trying the cosine rule,
Trying the cosine rule? All right, so let me just write down the cosine rule. So the cosine rule, let me write it in blue. I'm writing it in green because we're trying to find this angle over here. So the cosine rule says a squared equals to b squared plus c squared minus 2 times b times c times cosine of a. And again, in this formula, these A, B, and C, they are all arbitrary. You can call anything, anything. What you need to make sure is that the side A is clear because you need that corresponding angle A, all right? But you can call B and C anything. As you can see here, you know, you have D and C and A. You don't have any B, all right? That doesn't matter. So let's see how we could use the cosine rule, or if we can use the cosine rule. Go ahead. Oh, so much silence. How could we apply the cosine rule?
Since as you don't have the little a, so you'll find the little a first.
I don't want, but remember, so we're trying, this is what we're trying to find. We're trying to find angle D.
Well, you can try find this first before you go right over R. You try find.
Hold on. When you say hold on, when you say try find this first, what is this?
The little a.
Little a. All right. So this is the problem now. Little a is just the generic formula. It's just a general formula. In our triangle, little a, we don't have a little a. I don't know if you're understanding. This is a general formula. So this formula is saying if you have a side, and we're going to just call that side A because all triangles are different. We're just going to call that side A, right? If you have a triangle and you have a side A, they're squared. If you have the side A and you have the angle, the opposite angle, which is capital A. This formula can apply to solve it. The other two sides, you square them, add them, minus 2 times the other two sides. That's all this formula is saying. If you are to apply yes, go ahead. Somebody said this.
I'm saying, so basically, the cosine rule is basically to find the side, the length of the side, and the sine rule will go for the angle.
No, you can find side or angle with anything, with both of them.
With both of them?
Yes, you can.
Okay.
It depends on the information that you get. So in this case,
okay.
so remember we've used this cosine rule last week to find side already, and we rearranged this formula to find angle already. So you can use the cosine rule to find either the side or the angle, depending on the information you have. So let me give you an example now. If we are working this formula, if we are working this triangle here, right? In this triangle, I would look at it and I would say, all right, this is my angle. I have angle 34 here. This is the only angle I have, right? In my cosine rule, I only need one angle. Everybody follow me so far?
Yes, ma'am.
That is the angle that is represented as A down here, so right? I only need one angle, which is this. But if I have this angle, if I have this one angle here, this is the opposite side to that angle. So whatever the length of this is, it will have to go here because this is the side that is opposite to this angle here. And then I can use B and C, or we can call anyone C or B if we want, here and here. No, but the challenge is that I want this angle, which is angle D. If you follow me? So I can use it. I can try and use the cosine rule to find angle D. To use the cosine rule to find angle D, I can just reword it and say this is D squared, and then this over here, so I can call this D, because what matters is the relationship, right? So this is cosine D. This is me trying to see if the cosine rule can be used to solve this triangle. So I would want to find angle D. Because I want to find angle D, it means that this is the only unknown I can have in the formula. You agree with me?
Yes.
If I'm going to use this formula as it is to find angle D, I can't have any other unknowns. I'm going to need to know everything else so that I can rearrange a formula and I can solve for D, right? So the next step then is to go and see if you have all of that information. So do you have, so let's first look at D squared. D comma D would be the side opposite to angle D. So if this is angle D, this is the side opposite to it. Follow?
Yes.
I would have that.
Clear.
I would have that. So this would be 10. I would have that. And then you could have B squared. Could use this as B squared and that as B squared. You follow me so far? And so we find out now that we could use the cosine rule to find angle D. Is that what we were asked to find? ABC. We could use the cosine rule to find angle D, because if this is angle D here, that's our unknown. We have the two other sides, which is B and C. So we can call this B for argument's sake. And we can call this C, so I have that. And then the opposite side to angle D, no, we don't have B and C.
No, we don't have.
We don't.
All that.
Come here, call the same thing. No. Same thing, we don't.
Yeah.
Sorry.
Yes, miss, that's why I said probably you have to work out and find that so you can
what is
put
that?
it in.
What is that?
Yeah, all me do it could I find me
No.
I call down big A up here and carry to the
all right, hold on, carry on. Now you see, I'm not seeing what's on your paper, you know. So you see when you talk to me, you can't say find that.
Sorry.
Carry it up, you have to say find what?
I was saying find the little A as me do it, find the little A first. All right, Chuma have the big A up here, and me carry the arrow coming down, but just call it underneath the DC little A.
Okay, so you find DC first. All right. You find DC first. Great. So let us see now. Let us find DC first. That is what I did. I found DC first.
Yes, that made it mean. Say, find DC first.
Yeah, but yeah, say find little A, you know. Yeah, said carry that up there, so put that there. That means you can't see. So you have to tell true. So you can't.
Yes.
So
that's exactly what I did do.
You found DC first?
Yes, with the cosine rule.
All right. So here is the thing though. I said to you guys, think about it and then let me know what you come up with. I wrote these questions already, you know, but I need to go through it step by step with you, to go through the thought process with you. So when I say tell me what you get, it's not trick you. I mean, tell me what you did, what you went through. That is what I want. Right? Me have my fear for them, me work them too before me come class, you know. So I am going through these steps. I'm going through steps to make sure that you understand how you go through thinking about the questions. So let's work DC first and see what you get. So let's use the cosine rule. So a squared equals to b squared plus c squared minus 2ac times cosine a. All right. So you're going to have 10 squared plus 10 squared minus 2 times 10 times 10 times cosine 34.
36.
34?
Yes.
34. So you're going to have
Yes, Miss, 34.
minus 200 times cosine 34, which is 200 minus 165.807. You getting the same thing?
So far.
34.193. This is a 3. Let me write it properly. Do you get, have you gotten the same thing so far? Answer back.
Yes, miss. Yes, miss.
Okay, so now we need to find the root. And then you're going to get A is equal to 5.885.
May round it off and put it to 5.85.
Doesn't matter, it's okay.
Okay.
All right. So now you find DC. So we can just put in DC as 5.85. So now that you find DC, so Shana, that's what you got as well?
Yes, ma'am.
Great. So now that we find DC, what is our next step? Because the DC is not what we were told to find. We were asked to find angle D. So how do we now find angle D?
Miss, now we can use the sine rule.
Now we can use
because
the sine.
We have, yes.
Great.
Because you'll have hold on.
Can I erase this? I don't have enough space.
Yes, miss, you can erase it because we have that already. We do that already.
So the other young lady drop off of the call. All right. So sine A over sine A equals to B over sine B. Right? So tell me what you use for your A and what you use for your B.
All right.
So let me
for
just
A, for side A, I had 5.85. I rolled it off.
No problem.
Over sine 34.
Okay.
Equals to 10 over sine B.
All right, great. So then we end up with sine 34 times 10 equals to sine B times 5.85 sine 34 times 10 all over 5.85 equals to sine B. I'm just going to carry it up here. Then you're going to have, let's see, sine inverse 5.59 over 5.847 equals to B. And your answer, what did you get for your answer?
Almost there, almost there.
Enough, but I think I'm done. That's how I rush through it.
No.
All right, work it out and tell me. I put mine down, but I missed, I didn't go step by step because I thought you guys worked it out already. So tell me what you got for your answer.
I got 72.746 or 72.75.
What did you,
Around there.
175? All right. What did you
Yes.
get, Carry on? Carry on, drop asleep.
No, don't drop asleep. But bad breed, so not give me trouble. So you have to bear with me. Um, wait, so we must find the sign. Also,
So Shauna, your answer will be correct. You see, but the thing is, why I get that answer, when I plug in my signs in the calculator, so when I plug in sign 34 in the
You
calculator,
don't round it off.
round it off, I just multiply by 10 same time. So I'm going to get that answer like, but it's fine. But yours
Okay,
is,
miss.
don't worry about it. Karen, I'm waiting on you to work so I can move on. It's just two of you in the class, you know, so. Right. You get all the attention on you. Karen, not finished yet? Sister,
no, Miss me, no, something wrong with my. It looks like something wrong with my calculator. I didn't maybe. Missy look like me I do something wrong. Arm lost.
all right, tell me where you were, tell me where you had the same thing. Did you have up to the second line, 5.85 over sine 34 equals 10 over sine b?
5 point.
Did you have up
Sine.
to that?
Yes.
All right, and then you cross multiply.
Is that cross multiply?
Yes.
Oh, so me I got sine b within over sine 34.
All right, Shauna, it's start working this other one as yet, BAC.
I'm trying to figure out that part of it.
Okay, all right, go ahead. Karen, can you take off this? I want to clear the
Yeah, me take it off.
you take it off already. All right.
Yeah, so this different. It look like you do something for this calculator. Wait to say that. Get confused with that side. You have to do this when you go. Do this over again. Go and go sleep.
All right. So tell me what you're thinking now for finding angle BAC, which is BAC. So yeah, which is this part here. So I'm going to put it in red. So I'm just going to take out some of these stuff that's inside the triangle just to make it a little bit more, just to make it less crowded. All right, so tell me what you get now, waiting on you guys to tell me.
All right, Miss. What I was saying, what I was looking at, I was saying that since angles on a straight line, you normally get them at 180 degrees, right? I would first find angle C and subtract that from 180 degrees to get the other side of the angle.
So you would first, hold on, let me
From the
see.
first triangle,
You would first
find
angle
from angle
this one.
ACD.
So
No, one at ACD.
ACD.
Yes, I would
Okay.
first find that angle. After doing that, I'll subtract that angle away from 180 degrees to get the other, to get ACB. And then use that to get angle A.
Okay, so you would use angles in a triangle equal to 180 degrees to get the answer?
Yes.
Okay.
But first, find angle ACB first.
Okay, all right. So you could do it that way. That way is perfectly fine. But that's a two-step way. So if you're in the exam and that is the way that comes to your mind to do it, that's 100% right.
Okay.
You can work it that way. However, I'm going to show you a different way, which is the same concept, angles in a triangle. But I'm going to ask you to view the triangle. Instead of viewing it as two triangles now, view it as one big triangle, angle A, D, and B. A, D, B, right? So in ADB, all the angles still equal to 180. So you just find angle D. This one here, you just find that.
You could add all the three angles,
all three of them, and then subtract them from 180. So what I would say is angles in a triangle. Angles in a triangle are equal to 180 degrees. So the angles in triangle A, D, and B should equal to 180 degrees because it's a triangle and it follows the rule, right? And so I'm going to add all of those angles and then subtract it from 180 to find the angle up top there. So we're going to have 34 plus the 42 degrees plus whatever you had gotten for your angle D. I had gotten 73.2. You had gotten 72.8 something. So you can use that. 180 minus, I'm going to get 149.2. Then the answer would be 30.8 degrees. So it's a similar thing to what you were saying, except that you would have done it in a two-way.
So you're saying this, you always use this rule, what you're giving here?
No, carry on. You just have to reason to it. You just have to look on the triangle and figure out just as the same as I always say.
No, just make sure say it's 180. It's always 180 degree, right? That you're saying.
No, I'm saying to you that one of the rule is that angles in a triangle, any triangle, all the angles add to 100. Always.
Always, okay. You just want to say it always 180 degrees.
Yes.
Okay.
All right. So that's that for that question. Any questions to find angle? That was that angle BAC?
Yes, miss.
Question? Are you okay?
That's okay.
That's okay. All right. Now, so let's go ahead and find, what are we finding now? The length of AB.
Length of AB.
Let me just clear this. All right, so we can go ahead now. Tell me what you're thinking for length of AB.
For length of AB, could use the sine rule.
You're trying to find this right here, so.
Using the sine rule.
All right. So you have this angle. Let me just put in this angle. What we did find for this angle again, I had 30.8. So we have that angle right there. And we know that this is 10. So we can use sine rule.
Yes.
Sine rule is equal to all right. So what are we going to call our A now based on what we have? So we have this is one angle, opposite side. What are we trying to find again?
The length of AB.
Trying to find AB. So we would have one angle, opposite side.
Mm-hmm.
We will need to find this angle right here. So we would need to find this angle right here, angle C, so that we can use it to find the length of AB there. So Shauna, this is now where your finding angle C would come in useful.
Yes.
You see that? Right. So I had found angle C right here before. So what did you get for angle C?
For angle C, you would have 38.8 plus
38 to 32. Okay.
Would be 80.8 thereabouts.
80. No, I got more than that. Let me just work it out quickly. So we can use angles in a triangle again.
That should have would be about 199 point something.
I got 107. Just check it for me. So we'd have 42 plus 30.8. 181. And when I added that, I got 72.8.
Yes.
And then I got 107.0. Right?
That is 170.0.
107. So this would be 107.2. So we could use the sine rule now. So we have 42, this angle, and this is the corresponding side, which is 10. And we now have this angle opposite to AB, and we can use that to find AB. So we can say, so for the sine rule, so our A would be 10 over the sine of 42 equals the B that we're trying to find, which is AB, and over the sine of the opposite angle, which is 107. So we would have sine 42 times AB equals to sine 107 times 10. AB equals to sine 107 times 10 all over
sine 42.
So you plug that in your calculator and you should get or something close to that. Plug it in your calculator and tell me what you got.
Come on, calculator. 107 divided by
14.27.
You got 14.27?
Yes.
That seems a little too small. All right, I was reaching mine. Tana, let me know what you get. Let me just find my calculator. Calculator.
107 10 divided by
So carry on. You just plugged in the information that you see on the screen.
Yes.
Okay, so I'm just going to do it again just to make sure. Sine 107.
Yeah, I have 107. You know, put the point 20.
107.2. Okay.
Times 10 divided by sine 42 equals 14.276.
Okay. All right. 107.2 times 10 divided by sine 42. Yeah, 40 because I didn't put the 0.2, that's why.
Okay.
No,
Yeah. So it's 14.276. So you can call it 14.28. The answer actually asked us for the question actually asked for the answer to
Three
two.
significant, a 3 or 2.
three
Wait there.
significant figure.
Is it 3 or
Three
2?
significant figure?
Yeah, it
3
asks us
significant figure.
3. So if it asks for 3 significant figure, then it will be 14.3.
Okay. Or you round up.
Yes, 3 significant figures. So 1 would be 1 significant figure, 4 would be another 1, and then 3. You shouldn't have more than 3 since the ask for 3 significant figures. So that is wrong. The answer is
Oh.
4.3.
Wow. This is long.
Well, this is math. Once you know how to do it, the long don't matter. It feels nice when you're working it and getting the answer.
I forget the full marks. If you do it halfway, you never get it.
Yeah.
You definitely won't. All
But
right.
miss,
Yes, go ahead.
okay. Go ahead. No, go ahead.
No, man, I was going to move on so you can just tell me, ask your question.
Miss, you can go ahead because we're finished.
Okay.
We're complete.
Are you okay?
So far.
All right.
Getting there.
Getting
Getting
there.
there.
At the end of the road, this is now. With
Miss,
trig.
at one point I didn't like trig,
What?
but
What
you
did I
guys made it fun.
Mm.
I
Great.
had a math teacher that turned me off from trigonometry, but you guys made it fun.
Great. Good stuff. What this me do you know from screen? So you know see what to take place.
If you blank out the screen, turn
I
it
don't know
black.
what to do. I'm going probably okay. Probably have to I was going to call sir, but sir tired work, just a mash up there. All right, so we are going to look a little bit now on a little, geez, I'm gonna do the same thing again now. A little thing called bearings.
Bearings.
Yes, bearing. All right, so let's go. And this bearing going to feed right back into trigs. So it's it's under the same topic of trigonometry. All right. So
But
usually, go ahead,
wait,
Karen.
miss, I did have I have a past paper here and I see something with bearings, but I not trig it coming in one next. It yes, it
Hurry up,
in
go send
our
me that
next.
paper there.
It in our next part of the one question. So you tell me say bearings coming in all of them.
Bearings is under trigonometry, but you know it's a triangle. It can work out to be a triangle as well. So you
Yes,
know,
if the bearings in the scale drawing, the one with the scale, like if you get map,
yeah.
yes, it have bearings in it. So
But you don't know what bearings yet. So
oh
so that we are the bearings no.
no, so more understand if the bearings itself
Yes.
work for the two of them.
Well, you have to understand bearings first before, and then once you understand bearings, I think your question will be answered.
Okay, cause the stuck panda one day, no, completely.
All right. So let us try out some bearings now. Yes. No,
Yeah.
bearings have to do with representing your position, right? So I'm going to start off by drawing. I don't know why I draw Celine, right? Celine, but
Alright, so
It
that is
perfect. The
no,
by the way I use
how may I do it? I can say I be a foolishness.
how you use so it perfect. It don't look lead to that.
All right. So this is normally how we would tell direction, right? When you're
Yes.
telling direction, you tell direction in terms, well, you should tell
North,
direction
east, west.
in terms of those four main compass points: north, south, east, west.
Mm.
Important for us to know this when you're doing bearings, for you to understand which is where, because even though bearings take the direction a little bit further, sometimes it refers to north, south, east, west. So you need to know where they are on the compass point, right? So I don't know, some persons learn it by saying naughty, elephant, squirt, water,
Eh?
or uh,
That was the new to me.
Miss repeat?
I'm going to write it naughty, elephant.
Naughty.
Naughty elephant, squirt, water. I'm gonna write that one.
So some people remember it that way, to say naughty elephant squirt water, or some people just remember we. Because most people know north and south, right? North at top, south at bottom. And you just say we, just like when you write it. W over to the left and E over to the right, right? So
Mm.
whichever
Okay.
you use, you can use it, right? But you need to know where is north, where is south, where is east, where is west. So in case your question say something travel 30 degrees, you know, understand to a particular, this a particular point on the compass, direction, you can appreciate what that means, all right?
Yes,
Okay.
miss.
That is the first thing. So
All right.
this is how you would normally this is how you would normally tell direction, by saying north, south, east, and west. However, we can, extend this direction from a mathematical perspective to what we call bearings. And this is just another way of representing bearings, in which it's not just north, south, east, west now, it's incorporating angles to describe the position of something, right? So instead of just saying north, south, east, west, which just means top or one on the sides or bottom, you're now giving it a more expanded description when you use bearings, by just by incorporating the degrees to it now, some angles in it now, right? Now, one thing that you need to remember, and this is key when you're doing bearings, or this is one of the key things, is to remember that the angles that we speak of in bearings are always measured clockwise. So the
Okay.
bearings angle, I did not write it, always measured clockwise. And clockwise mean the direction of the hands of the clock, all right? So
Yes.
from north, it goes in this direction, always in this direction. This is clockwise,
Uh-huh.
yes?
Mm-hmm.
So whenever you
Yes.
talk about a bearing angle, if them say it is 20 degree, you have to measure 20 degree this direction, all right? You can't be measuring it the opposite. It can't go this direction. That's wrong, yes? So that's another thing important for you to for you to understand. The bearing angle is always measured in the clockwise position. Clear so far?
Yes, yes.
Yes, miss.
All right, good. So the other thing is that bearings are always given in the context of a north line. And so whenever you give up, whenever you get a question with a bearing and it say, this is the bearing of P, it is always from north. So if you get a bearing question, the first thing you must always draw, is a north line. Your north line is the first. What is wrong, man? The first thing you draw is a north line, because your bearing is always referenced from the north line. Yes? So if them say a bearing of P, then you know your north, and P now becomes in position of your north, right? So you following that?
Let's go over that again.
All right. So whenever you get a question that so maybe it's best for me to work it, for me to explain it, giving you an example.
Mm.
If I give you a question that says, before I go there, so I want to point out something to you first. Let me just draw back the compass. All right, so this is north, elephant, squirt, water, right? Now, between all of these are 90 degrees angle, right? So between north and east is a 90-degree angle. Between east and south is another 90-degree angle. Yes. Between this and that, what is that now? South and west is another 90-degree angle. And between here and here is another 90-degree angle. Everybody follow? Follow me so far?
Yes, because the whole of them have to add up to 360.
Great. So it's another 90-degree angle. So then it means that if you're measuring something, so, well, it means that between north and south, that would give you what? You're measuring
180.
180. And if you measure from north to west, that give you what?
From north to west, 180 plus 90. 270.
270, etc., etc. If you get a bearing now that is halfway through here, and it is 45. When you are measuring your bearing or you're writing your bearing must always have 3 digits. So if you get this bearing, I'm going to put it in purple, and it is halfway between north and east, which we know is going to be 45 degrees. We don't just write it as 45, we write it as 0.45. Follow? So
okay.
Okay, because it's coming out of 360.
Yes, so it must always have 3 degrees, three digits, sorry. So north is 0, 0, 0. This will be 45. Halfway between is 45, and then you'd have your 90 right here. So, and if you're measuring, something that is 30, you would record it as 030. If you're measuring a bearing that is 50 degrees, you record it as 050. So your bearing must always have 3 digits. Clear so far?
Yes, miss. Let me write it down. Your
Yeah.
bearings must okay, yes, miss.
I'm just writing down a little question.
Mm.
All right, now, so this is I'm going to just demonstrate what I was saying to you earlier by using this question over here. Let me just highlight it for you. This is the question we're talking about. Wait, sorry. This question here, that's what we're doing. So it says a bearing, the bearing from a point B, the bearing of a point from point A is 40 degrees. And it is, and you can notice it is written with 3 digits, 0, 4, 0. Now, when you want to work in bearings, you almost always need to sketch your bearing, right? Always need to sketch your bearing. You have to sketch it to see where it is set. So let us try and sketch this now. It says a bearing from a point B, no, a bearing, something is wrong with this. A bearing of a point B. So this will be off. All right. So at the bearing of a point B from a point A is 40 degrees. So once you hear that you're doing a bearing, the first thing that you need is your point of reference. Not a point of reference, it's your north line, right? Because your bearing is always, drawn from your north line. You have to have your north line. Why? Remember that your north line is 0, 0, 0 degrees, right? That is the start of it, 0, 0, 0 degrees. So you have to always draw your north line. Follow me so far?
Yes.
Notice the question I said nothing about north line, it just said bearing of a point B from point A. And since it's bearing, first thing I draw, my north line. Because north, as I drew it over, remember when I drew it over here, so I'm going to say north, it is 0, 0, 0. Then this is 0, 9. Then this is 0, 180, and so on and so forth. So I have to draw north. North is the start. North is 0. Good. So let's go to the question now. At the bearing of a point B from a point A. So usually from point, this is what we call the point of reference, from a point, right? And where it says from, this is what we call the point of reference. And that goes right under your north line. So this is your point of reference. This is where it starts from. It's a from a point. So you measure the bearing of something, but it is from this point. You understand? So it's like you say, you go town, but you are left from Spanish Town. So if you want to measure the distance, you have to measure it from Spanish Town because that's where you start. That's your point of reference. Yes?
Yes.
Follow? And then it's the bearing.
So far.
The bearing from a point A, no, like the bearing of point B from a point A is 40 degrees. So we know that point B is 40 degrees. It's 40 degrees moving from point A. So this is what 90 degrees look like. Halfway there, so it's 45. So that means a 40 is going to be somewhere like that, right? And it's not drawn to scale. So you don't have to worry about it being perfect. So I'm going to just draw my line somewhere like this and call this B, right? So the bearing of point B, well, of point B from point A is 40 degrees. So I know that this angle in here, and I'm going to draw the arrow to show that it is probably not the best color, to show that it is clockwise, going in the clockwise direction. It is 0, 4, 0. It is 40 degrees. Everybody following me so far?
Yes, Mr. Following, but Miss, you're going to need a protractor to do this?
No, you don't need a protractor.
And graph paper.
You don't need a protractor.
Okay.
You don't need a protractor for it, right? So this is it. At the bearing, a bearing of point B from point A is 40 degrees. Let me give you another question. And this is just to get you to learn how to draw the bearing diagram, because when you get bearing questions, you're going to have to draw the diagrams, right? So I'm just teaching you how to draw the bearing diagrams. So the bearing of P from Q is 130 degrees. So let's go and let's look at it. So this is a bearing diagram. So the first thing I'm going to need is my north line, right? Underneath my north line is my reference point. Where is it coming from? So I said the bearing of Q, how about this? The bearing of P, this don't even look like P.
Looks like Q.
No,
It don't look like P.
a P, this would be about Q. A P, I just threw the stick not at the right place.
No, me did check say our lollipop with one stick in the middle.
P, all right. So the bearing P from Q. So from Q, Q is a reference point from Q. So Q is what is under the north sign right here. And it said the bearing of P from Q is 130. So P is 130 degrees from Q. So you know what 130 looks like. This is 90. This is 180. Between 90, between this, so this is 0, 0, 0. This is 0, 9, 0. This is 180. Halfway between 90 and 180 is what? 45 plus
135.
135, right there. So 130 are gonna be something like right there. So you understand? So it don't have to be perfect again. Just know that this is not drawn to scale, right? So P is going to be somewhere right here. So, and always remember to put in your arrow. Your angle is measured from north in a clockwise direction. So this 130 is from the north in a clockwise direction. That's 130 degrees, right? So this is a bearing of P from Q. Yes? Wherever I say from, that's a point of reference. That's right below the north line. And then whatever else comes after. Yes?
Okay.
Any questions?
Not right now. So far, so good.
So far, so good. So let's go on the bearing diagram. All right, let me just, to make my life simpler, I'm just going to change these. So I'm going to give you another one. Carrie Ann, are you okay?
Yes, miss.
All right, so we're going to do the bearing of J from Z is 98 degrees. So the bearing of J from Z is 98 degrees. So bearing diagram, first thing, north line, right? That's your north line. The bearing of J from Z, so that's your point of reference, see? From Z, point of reference, so that goes underneath your north line. And you're looking for the bearing of J, it's 98 degrees. And just a little sketch here. This is 90, right? This is sorry, this is not a 180, but you get what I mean. This is 90. So 98 is going to be a little bit underneath that, right? So 98 degrees. So this would be, make it a solid line. This would be J, and the angle is 098, because it's a bearing. So remember, it have to have 3 digits in it. All right? All right, so let me give you one more bearing diagram, and then we wrap up this portion with a question that twins bearing with some trigonometry. So let's do The bearing from Y, the bearing of Y from Z is 300. You guys have the Mathematics for Caribbean Examinations textbook by Conrad Archie?
The
No?
one I have is the long time version.
Okay.
Long time.
Okay. All right.
Mine goes from I was back in high school in the early 2000s.
Right. All right, that's fine. I just wanted
That
to know.
one, all right.
No. I have a question. I only wanted to know if you had it, but since you don't, that's fine. I'm going to take a picture of it and put it in the group, or you can look at it. I know it's too much to read right now, to write. So I don't want to have to
Okay.
write. So go and draw that bearing for me while I take the picture and put it in the group.
What's that, 300?
Yes. All right, so the question we're going to do together, I've sent it in the group. You should see it now. That's going to be the question that we close with this evening. So before I do that question, let's just go ahead and draw this bearing. So the bearing, we will start with our north line. The bearing of Y from Z, so it says from Z. So Z is our point of reference, right? From Z is 300. So let me just sketch back lean hand thing. Let me just sketch back that. So this is 000, this is 090,
180,
180, this is
270.
270. And so you know that 270, 300 is going to be somewhere off right here, right?
Yeah.
So this,
That's how I put it.
yeah, so it's going to be somewhere like that. Don't have to be perfect. So this would be Y. That would be Y. And then the angle now, I'm going to put the angle in red. It comes from the north line in a clockwise direction. So this is going to be the angle here. That is 270 degrees. No, like 300. But 300. So just bear in mind, it's not this angle on the inside here. It's from the north line in a clockwise direction. That is the angle that is 300 degrees, right? Everybody clear?
Yes, me.
Yes, it is.
Good, great. So now that you've drawn a few bearing diagrams, let's go ahead and attempt that question. And then you can go home. Last week we were here until about almost 10. We're not doing that late today. We have our proper thing now, so we're good. So let's go through the question that I had sent to the group. Let's work through it together. Sir is going to send you, I think two or some more of these types of questions that you can work through. But I'm going to just work through this one with your help. We're going to work through it together just to give you an idea of, some of these types of questions that you can encounter for your exam, right? They're not going to be as simple as draw them little bearing diagram there. I just gave you those to show you how to draw it because you must know how to draw them to answer bearing questions, all right? So the question that we're working with, it says the bearing
Bearing of a
point A from point B. So let me start by putting my north line, and I'm going to put it exceptionally big because I want to make a point.
Mm-hmm.
And so that's our north line. So I need to identify my point of reference. So I'm looking for that from. So the bearing of a point A from point
Point
B.
B.
Point B is my point of reference. So it's here. So A from point B is 30 degrees. So I'm just going to put 30 degrees probably here. Yeah. So this is going to be A, right? And then this angle here, because it's from the north line, is going to be 30 degrees. What do you follow that?
Yes,
Yes,
miss.
All right. And it says, and the bearing of a point C from point A. So now it says the bearing of point C from point A. So point A now becomes a point of reference now, right? Point
okay.
A now becomes a point of reference because it said the bearing of C from A. So that means that A now becomes a point of reference. I need to put a north line where A is. Everybody see why I do that?
Because it now becomes a point of reference.
Yeah, because the question said, and the bearing of point C from point A is
Yes.
120 degrees. So now point A is my new point of reference, and the bearing of this new point C from A is 120. So if this is 90 and this is 180, 120 should be somewhere like right here. So right? So I'm
Yes,
going
ma'am.
to put my 120 sort of like here. So my point C is that, and it says C, well, C is coming from north, this north here in a clockwise direction, and it is 120 degrees, right? So this is just interpreting the question. So I started out with my first north line because I knew I was doing a bearing drawing. It says a bearing of point A from B. So from B, B was my first point of reference, and I put it there. And then A was 30 degrees from B. So I just find 30 degrees and have my A, right? That was the first part. Everybody comfortable with that?
Yes, ma'am.
Then the second part says, and the bearing of a point C, which is a new brand point. So point C is somewhere out here. It is from A. So A now becomes a new point of reference. So because it's a new point of reference, I draw a north line, and then I put C, as the question says, 120 degrees from A. This is how I got this portion in blue. You seen that?
Yes, ma'am.
All right. Kerry?
Yes, miss, I see it, but the 120, it look like you should have come down some more.
It no matter, it's not drawn to scale. It's not drawn to scale. So it don't matter substantively.
Yes, but the question not finished.
We're not finished, but this but all it drawn don't really matter because it near there. It not drawn to scale. So don't worry about it.
No, man, me I said the question look like it not
No,
finished.
it's not finished. One more sentence is there. So it says
Mm.
if AB, so we can find AB. AB is this AB. If AB is 80 meters, so I can put 80 meter right here. So AB is 80 meter. Everybody seeing that?
Yes, ma'am.
And AC, which is this A times C right here, so is 150 meters. So this is 150 meter. It says, what is the distance of C from B? So C is here and B is there. I'm just going to draw this dotted line just to indicate that this is what is being asked of us to find. Yes? What is the distance of C from B? All right? Cool. Let's start working it out. So we're going to have to use the sine or cosine rule. But as you can see, we have a triangle, A, B, C, and we don't have any of the angles in there, right? So we have to find a way to find some of the angles that are in there. Everybody agree with me?
Yes, ma'am.
We have to find a way to find some of the angles. Now, since we are wanting to find this line here, BC, the angle that we probably should find first, that it more concern us most, is the opposite angle, which is this one here, angle A. I'm going to put it in yellow, right? Because it is opposite. So you probably would need to find that one if you're going to use the sine rule or the cosine rule to find BC. Following?
So far,
So far, good. So how are we going to find it? We only have the angle outside it. So we need to find a way to find this angle. Now, one interesting thing we're going to do, well, not interesting, but just I say it's interesting, right? We're going to use. Now, when it comes to bearing, you know that this is a north line, right? And with a north line, you can have if you carry it all the way down, this is your south line, right? Follow me?
Yes, Miss.
So the point I'm making is that this line, because it's a bearing and this is north, you can carry it all the way down to make south. So then what you can do from this north line here, follow me, you know about Z angles, right? Anybody know
What
about,
is it?
you know about Z angles?
Z angle. No.
No, but Shauna, you know about Z angles? Shauna, you know about Z angles? Shauna gone? Carry on, you're there?
Yes, Miss, I'm here.
Look like Shauna drop off. I'm going to just give her a minute or so to come back. I don't want to.
Yes.
Yeah, let me just give her a minute or so to come back on.
woman.
No? All right. So you're going to crash course in it because you should know, but you don't. So let's do the crash course. You know what a Z is, right? It's not a trick. It's a normal Z, just like when you write Z.
Yes,
Like
miss.
when you write Zachariah, you write a Z like this.
Yes, miss.
That is the Z we're talking about. So as far as
Okay.
angles are concerned, we said angles in a Z angles are equal. So this angle is always equal to this angle.
Okay.
Yes? So if this is equal to 50, this is equal to 50. If this equal to 100, this equal to 100. Yes?
Okay, miss.
Same to carry on when you were gone.
Oh,
If you turn the Z on its side like this, it's the same thing. You turn the Z on its
okay.
side. This is equal to that. Yes? Follow?
Miss, you're getting low.
I'm getting low, sorry. So I was saying if you turn the Z on its side like that, this angle is still equal to this angle. Follow?
Yes.
Yes,
And
miss.
if the Z is back way or front way, whichever way it is, like
That,
this,
that one.
like this angle is still equal to that angle. Yes?
Okay.
So that is a rule that we're going to use to help us solve this bearing question here tonight. And that's how we're going to start because we don't have any of the interior angles in the triangle. So that's what we're going to have to use to help us solve the question. Yes?
Yes.
Okay.
All right. So let us see if we can identify the Z in this. Remember, with this north that we had right here, the one in blue, the one from the point of reference A, I had carried
Yes.
it all the way down to show you, to say that, you know, you can carry it all the way down to give you the south part of the compass as well. That being said, if you follow, from the north in black, where you are seeing my pen moving, to follow that north in black, come all the way down to B, and then go all the way up to A and come down to the south, you have a Z. Do you see that?
Yes, Miss.
Yes,
Great.
miss. You,
So then this 30 degrees
is the same. It would be the same
It
30
would be same
at the end part.
30 on line BA.
It will be the same just for here. So
Yes,
because remember that the line comes down right here. The south pole part of the line comes right here. So this will be where the Z is. So this will be 30 as well. You see that?
yes, miss.
Great. So that is 30. All right. So if this is 30 right here, you know that this is 30. Give me a minute. I'm just going to pause the recording. I need to. Oh, so I was saying, so we got the first part of this interior angle because the only part of it in the car, you notice the rest of it is still there, right? So this part is 30 degrees and we find that part because of the Z angle. Now the other part over here, so how can we find what this piece measure? Any guesses?
The end part, that piece there.
Yeah, this part that
Oh,
we don't know right here. So
That's
I'm going to color
if
it in orange. This part in orange right here. So
if these are the Z and this of the
you'll
same.
subtract the 120 from 180,
great,
seeing it
because
on a, it
south
would
is
be
a
on a straight line.
north to south is a straight line, and angles on a straight line is 180. So
Yes,
if you subtract 120 from
180,
180, this would
60
give us
60,
degree.
60
60
degrees.
degrees,
So then that means the entire angle in here so measures what then? 30 plus 60,
90 degrees,
90 degrees.
90 degrees.
Which if you notice, it don't
Oh,
look
so
like
it'd be a right angle.
it's supposed to be a right angle
And
triangle.
it don't look like a right
It
angle.
don't look like it. That is why I say things are not drawn to scale. So I'm just going to rub it out in the middle here, so just to create some space to write my 90. But I just wanted to see how much work we have to go through to find the interior angle of the triangle. Understand? So that is how we have to break it down and, just work our way through finding that interior angle. So are you comfortable with that? We'll probably work another one tonight, because we probably have a little bit of time, but you're comfortable with that? So
So
this,
far with that part.
so
Wait a
this,
minute.
this angle here is
Yeah.
90 degrees. So we're
Alright.
trying to find BC right here. So I will have this angle, and we have 150, we have 80. We can't use the sine rule, can we? No, but we can use cosine rule.
No,
So let's
cosine.
let's try the cosine rule. A squared, and I'm going to actually not write A, I'm going to write BC squared, just to say that I'm trying to find BC, this angle here, to make the point that it's just the ratios that matter. So BC squared is equal to, I can call this one is what? AC
Yes,
squared plus this one, this angle, this line here, which is AB, plus AB squared minus 2AC times AB times cosine for this angle here, which is angle A. All right. So AC is 150, AB is 80 minus 2 times 150 times 180 times cosine 90, right? So can you work out this first part? 180 squared, 150 squared plus 80 squared.
Oh, no, 22,500.
Mm-hmm.
Okay, plus.
so 6,400.
6400. It 28,900. Okay. I wonder if I do it right.
What
Oh,
you working on, Harry?
we do everything one. Just put everything in a one.
What that mean?
Ah, but just oh, I'm add up everything in the second row. Put everything in the second row. Punch in everything in the second row in a calculator.
And you get what?
So 28,900.
28,900 is for the first part right here. So, right. Because you notice I have zero for here. Cosine 90 is zero. And then if you
Oh,
by zero, give you about zero. So you're just going to have 28,900, which is just adding these two first parts right here, right? So then the next step is to find the square roots. And so BC
170.
170. No, line, not under the square root sign.
So that means the length of BC would be 170.
170 meters.
Okay.
Yes, so that is your answer. So what I'm going to do, I'm going to put a similar question like this in the group, and you can do it. And probably when Sir starts his class on Saturday, he can start by working that one out before he moves on to a new topic. But as you can see, you have to first join. If it join is incorrect, and if you place if you place the angles at the wrong place, then you're going to end up with your question, your answer can't be right. Nothing after that can be right. You understand? Which is why I always stress, draw your north line, get your angles. Your angle is clockwise from the north line, etc., etc. Because those things, even though they seem, annoying to say them over and over again, it helps you to remember, to recall that these things are important. Because if you draw your bearing diagram incorrect, the angles in your triangle going to be the wrong place, and then you anything after that going wrong. You understand? So we'll solve that one. Put it in the group, and you can have that one to play around with for the week. Also, wait a moment. Also for this week, please remember that you have